All right, so today's the 20th day of school. We didn't get to play the song, but there are 20 amino acids, the building blocks of life. Anyway, moving on. Can anyone name them all? I did once, and I hated biochemistry. Ugh. Okay. Should I go over the answers to the homework? Are you standing back? Sure. All right, no problem. This was the first question of the homework I just passed back. All right, and the first problem, the first major concern that I have about looking at your work is that people are using logs when they're not supposed to and breaking one or two little rules about logs, okay? First of all, you cannot combine the left-hand side. You cannot mush them together and turn them into a single term right now because you have a coefficient in front. So get your coefficients up into exponents. Excuse me. Oh, wow. I'm good. Good morning. Coffee. And this exponent can also go up. Now, this left-hand side, subtraction becomes division. It does not become the natural log of 2 to the 4th over the natural log of 4 to the 3rd. I've seen some people do that. They're turning this into this. And that's not true, because you're saying subtraction is division. No. Instead, what this really is this. Okay? That's really what's happening. Okay? So please don't make the mistake of saying natural log divided by natural log equals natural log minus natural log. That's not true. Okay? And now you can drop the logs, and you get 16 all over 64, which is 1/4. Okay, it's 4. And you should check it. And this whole left-hand side is numeric, some goofy decimal, right? And now you've got, if you plug 4 back in, you can take the natural log of 4, and that's fine. You're allowed. I mean, you can't take the natural log of -4, okay? You can't take any log of 0, and you can't take any log of a negative. Because remember, the graph looks like that, okay? You can get a negative number you can plug something into the natural log and hit enter on your calculator and get a negative number out of it, but you can't put a negative number into it. And if you get a log spitting a number out at you that's a negative number, that just means it's less than 1. You're dealing with something over here, something on the curve on the left-hand side of that root, all right? And under normal circumstances, unless you've got like something translating the function up or down or left or right, this is 1, okay? Because remember, if this was if this was the natural log of x, what that's saying is that the natural log of 1 is equal to 0, and that makes sense because this is log base e of 1 equals 0, and e to the 0th is equal to 1, which we expect, okay? So under normal circumstances, no translations, movements, flipping, any of that stuff going on. You can't plug in a negative number, but you can get a negative number out, all right? And you can't plug in 0, but you can get 0 out, okay? All right, next question on the homework. I think I did this one. Oh, okay. That's why was correct almost all the time on people's papers. Yeah, that was another gripe of mine from the other day. Remember, I had a list of gripes. If you're going to copy my work, copy it properly. You know, I mean, like, copy all of it. Don't skip steps or copy it wrong. So here, you want to get all your logs in one place. Just like all of your x's, you want them all in one place, you know? So we can do this. And now the subtraction becomes a division. And now you either apply the first rule of logarithms, or you can apply the seventh rule of logarithms. Either one applies, and you'll wind up getting 3 squared is equal to x plus 17 all over 2x. So rearranging, three squared is 9, multiply both sides by 2x, and you wind up with this. And so now 18x, x plus 17, 17 is equal to x. There was a 2x in the denominator, multiply both sides by it.
How would you apply the rule?
Huh?
How would you apply the seventh rule? It's not 1.
Right, and x equals 1. Okay. Dane Bramage, coffee. Thank you.
How would you apply the first rule or the seventh rule? How would you apply the seventh rule?
Okay. The seventh rule says that if I don't like a log, I can take the base of that logarithm and jack it underneath the logarithm to turn the logarithm into an exponent. Right. So, but what you do to one, what you do to one side, you must do to the other side. So, because we're equal opportunity mathematicians, and we get. See, whatever that base was, I mean, if that was a 12, you would stick a 12 under both sides, and then it collapses.
I just have to do that with 1.
Sure. And of course, you get the same thing again when you go. All right. Do I have to do the third one? Okay. Now, before we dive into newer material, I pulled some good IB problems, and I want to take a little while to digest those, okay? So I thought that they were fun. Huh? No, Nicole said she didn't want a test, so we're not going to have a test. Oh.
Are you being serious about this?
Yes, we're not going to have a test. No.
Not at all, or just not right now?
No, because I'm going to take this quiz as it. I don't want to take another class day out.
Okay, I'm cool with that.
I've taken enough time. Right, and the reason why was because, and honestly, and I mean, I don't care if you call it a quiz or a test. Anything that takes the whole block is a test. And this took longer than I wanted it to. The one I would have handed back, the one these guys are going to take, it took longer than I thought. And it was rather comprehensive. I mean, there were a handful of things that I didn't put on it that we did cover over the past month, but I can test on those later. And there was enough meat on that bone for me to say it was an evaluation of your skill level. So I think it was good. I mean, I don't feel like I need to over-test. I mean, let's be honest, what's the purpose of testing? There's 2 reasons. 1, to measure what you know, and 2, to expose you to things and see what you do under certain circumstances. So I'm cool with it, if you're cool with it. Anyone complaining? Didn't think so. Okay, let's do this. Ooh, let's start with something simple. Huh? You want to do this on the boards?
Yeah.
Go to the boards, please. Do I need to record this? Okay, so my advice, first thing off the bat, is to trust your instincts. When you look at this, the first thing that you should immediately recognize is that you're dealing with powers of 2, right? So since you're dealing with powers of 2, turn everything into the same base, okay? Oh yeah, there's a couple up here, grab one. You guys need an eraser?
Oh, wait, no, we're good.
Oh.
Right there.
He's good? Everyone need one? Should I be continuing to record this, or should I pause it? Do we need it? I'll keep it going. Why not? It doesn't hurt. I got erasers over here. They don't fly well. But. All right, so boil everything down into the same base. Turn 4 into 2 squared. Turn 8 into 2 cubed. Can't do that yet. And in fact, if you plug it back in, it won't hold. My advice is to make a substitution. Okay, so everyone got there, and I'm sure everyone's going to do this. Okay, now, you can't, okay, addition throws a wrench into a logarithm. You can't bust up a logarithm of x plus 1, okay? You could not apply a log to both sides right now. And the reason why is, first of all, you could apply a log, but it wouldn't get you very far. Because the log of this, first of all, if I took the log base 2, and don't write this down, if I did do this, this left-hand side would behave the way you expect it to. The exponent would come down, the log base 2 of 2 would go away. Fine, wonderful, that's normal. The right-hand side does not play that way because you've got an addition. And logarithms do not distribute, okay? You can't distribute a logarithm. You can't factor out a logarithm, you know, or something like that. You can't play that way, all right? Because if you think about it, there is counting, then there's addition, then there's multiplication, then there's exponentiation. All right, now, first of all, counting is kind of boring. So let's look at these 3 operations. Exponentiation distributes over multiplication. Multiplication distributes over addition. They do not jump 2 steps. Does that make sense? You can't add over an exponent like this. You can't do this and say, that doesn't work. Does that make sense? All right. So addition doesn't go over exponentiation, and exponentiation does not go over addition. Just like this does not turn into, you see what I mean? They don't mix. They can only go 1 step up or down, all right? If you want to go upward from here, this is a logarithm, and this is division. Okay? All right. Now, so I'll be honest with you, I've seen this kind of problem pop up in IB problems more than once as I've been flipping through and getting myself familiar with their style of testing. Yeah, by the way, yeah, you can't do this. If you did this, by the way, I'm just going to finish 2 to the x plus 2 to the third. You could not distribute that log around. You know what I mean? You couldn't do that. Esto no es bueno, amiga. Can't do it. So you're kind of stuck right here. So you don't. That's not what you do. And another thing, you cannot take a logarithm if you do not have an equal sign. I saw people doing that. Okay? People would just have some expression, no equal sign anywhere, and they just say, bam, there's a log. No. You can't do that. It's like saying, you know, uh, and I threw in the sign because I liked it. Okay? Another thing I saw that you really can't do is just say, done. Or worse. Huh? That's like, you cannot take a log of thin air. Okay? That's like saying this. And walking away. You can't do that. All right? A log is not a toy. It is an action. It is not a noun. It is a verb. Okay? It is an action upon a number. All right? It's like saying 3 plus. What's for lunch? You can't do that. You have to say it has to be acting upon something. So you can't just throw logarithms around willy-nilly. So I look at this and I say, I can't use a log. It doesn't get me anywhere. I'm going to use substitution. Now all of a sudden we got something we can play with. Sure. But what the heck am I going to do about my left-hand side? All right. Turning the left-hand side into an expression of A involves doing the following. Let's do this. Let's do it in real long form. You see that? That got rid of the addition or subtraction in my exponent. Because remember, if you go from the bottom line up one step, that's what you wind up getting, 2x minus 2. And now this becomes or just 1/4. Okay? That's how you can get him away from, ugliness, make him a little prettier. And now let's multiply everybody by 4. And this this right here is 8 times 4 is 32. And now we have a quadratic. IB loves, apparently, from what I've seen, I have seen things like this happen a lot. Evil, nasty, fangs and claws and goes bump in the night equation. I multiplied everybody by 4. I get rid of the 1/4. Okay. Quadratics. Make a crazy weird substitution, turn it into a quadratic in factor. I've seen it happen with logarithms. I've seen it happen with exponentials. I've seen it happen with trigonometric functions. They love it. I don't know why. They're crazy about it over there in Europe. I don't know. Factor and solve. Check your answers. Eliminate any extraneous solutions. Do not leave a bad answer on your paper. You won't get full marks. By the way, immediately after school today, I have a faculty meeting. But if you get here like right away after the bell, I can get you started on it while I go. Okay, but don't be a little late because I won't be able to help you start you on the test. You'll have to come another day. Okay. All right. On a part of it. Now, make sure you check your answers. Whenever you're dealing with logarithms or exponentials or anything like that, you want to make sure that the game still plays. All right, go in and always check your answers. No. Watch. Right. Multiply both sides by 4. You can't play with the base. Okay? Don't change that. That's what you wind up with. And what are your answers? Don't leave your answer there because that's not what it is. Okay? Your answers are not A equals something. Your answer is X equals something. And then you do your resubstitution. And that one is not possible. That one doesn't fly. Think about it. 2 to the x, remember what that graph looks like. That graph looks like this. Okay? It never goes negative. If you think about it for a moment, if I have a negative x, if x is a negative number, it's just getting really, really, really tiny. It's 1 over a number, right? So x can't be, 2 to the x can't equal something negative because that graph never goes negative. Does that make sense? Exponentials can't ever produce a negative number because all you're ever doing is dividing and dividing and dividing and dividing and dividing, and you're never going to get down to 0. I mean, well, first of all, you're approaching 0, so you could never go underneath it. So that does not fly, and that is my only answer. Only, and only 3. Sir? Huh? You can. It never hurts. And you know, if when you do that, you get 4 to the second, so 16 equals in that case 8 plus 8, and your 8 looks like a gamma. Okay, let's get that handwriting under control. Next question, please. Bailey. Here, take a look. From here, okay, if I took the log base 2 of both sides, just say -4, right? I can't take the log of a negative number. Okay. Don't get confused with a negative number and a negative exponent. Next question. Ooh, this one was, well, no, we'll do this one first. Simplify. I want to point out, there is no equal sign. No equal sign. So don't insert one. If an equal sign exists, then it will be there at the end. If the equal sign does not exist, it will not be there at the end. You can put your negative exponent up, your negative coefficient, you can put that up if you want, and then just mush them all together.
That looks fun. No, we'll find it.
No, 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 no. Wait a minute.
Could you?
You are dividing the first two and multiplying the third one.
Okay.
It's positive.
Could you put this to a plus, like take a negative 2 up?
Right, and then it goes down, which is division again. Right. You're good. Keep going. All roads lead to Rome. So, Eric, put that -2 up as an exponent and make that middle term now plus. And then you just multiply them all together, but one of those terms, since it has a negative exponent, is going to go down.
Oh. Wait, where's the negative?
Okay? This is one way of doing it. Okay? And then you can multiply them all together. This is one way of doing it. I will show multiple ways of doing it, but this is one of them.
Wait.
Huh?
Can you like also?
Who was the negative 2?
That's fine, and then it moves down.
Okay.
It's actually plus in your denominator. It's plus.
This isn't plus. Wait, so wait.
Yes, that factors. The middle term becomes a negative, because it's negative exponent, it comes down below. Okay. The way I always explained it was, in my grandparents' house, there were 2 floors. There was the basement and there was the main floor of the house. My grandmother was happy when she was upstairs and upset when she was downstairs. Negative when she was downstairs. My grandfather was happy downstairs, but pissed off when he had to come upstairs. Okay, so you can move them up and down. You just have to switch that sign. Beautiful, thank you. And now you can do all sorts of algebra 2 stuff. And that far right one is a positive exponent.
Oh.
No, 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 on top of the very, I'm talking about the first line, right? It's only the middle one that's negative.
Oh, I see.
You've kind of swapped things around a little bit there.
Is this as far as I can go? Or is there the
Actually, you've made an error or two. First of all, your denominator should be squared.
Yes?
Yes. Because it's to the -2. So it comes down and becomes a +2. You drop the exponent of 2. Look at Nikki's. So you can factor all sorts of stuff. You okay? Factor that as the difference of squares, factor out a GCD. Bailey. You're making it hard on yourself. That's the difference of squares. X plus 1, x minus 1. Factor out a GCD of an x. Yeah. Yes. That's it. You would wind up with a big polynomial over a big polynomial, and then you would have to factor that in order to simplify it further. You can simplify further. No, I was talking to her. You see how I did that? Factor, look, you got to look for those patterns. That's as far as you can go. No, you simplify it. Wow. That's as far as you can go. You could distribute in, but it wouldn't do you any good. No, it is the log of the absolute value of the log of x times 2. All right, so what does it mean when so we're looking for the zeros, and once we find them, we're going to multiply them together. What does it mean what is a zero? How do you find the zeros of something? But if I wanted to find the zeros of a function, how do I do it? Well, if g of x was 2x plus 1, what would you do? How? Point to it and say, there's x? No, if I wanted the zeros of it, right? If instead, let's go back to the idea. If you had that function, and I said, find the product of the zeros, what would you do? No, forget about graphing, forget about calculators. Oh, gosh. How do I find the zeros of a function? How do I find the zeros of any function? I don't know what you're saying, find x by itself. Just walk over to it and say, hey, okay, it's by itself. I mean, what do you mean? Thank you, you set it equal to 0. And then you get x alone. Okay? So I'm looking for the zeros of that evil beast. That's what I want. So remember, your target is x. So what am I going to do right now? What's the next thing I'm going to do? What am I going to write down? That is 2 times x, the log of x. Take the absolute value of that, and then you log that. I know, it's got fangs and teeth. It's evil. It goes bump in the night. But the fact of the matter is that if you can't get past the instructions, forget about solving the problem. Yeah, you can. Sure. 7. 7 is very useful. 7 is very, very useful because what 7 does is it gets rid of a log. I want to get x, which means I have to strip away that log on the outside. Then I have to, guys, it's a Christmas present. It's a birthday gift. In order for you to get to the thing on the inside, which is x, which you're looking for, you have to peel away the log. Then you have to peel away the absolute value sign. Then you have to peel away the 2. Then you have to peel away the log base 3. That's how you get to x. You have to peel it off layer by layer, okay? So how do I get rid of this log base 5? What's my favorite rule? Now it falls apart. Rule 7? Okay, let's go back.
I mean, I can do it. I just don't understand exactly.
Oh, wow. Don't go away. Okay. My smartboard has been invaded by demons. Okay, so according to the first rule of logarithms and the 7th rule of logarithms are the same rule. Okay, they don't look like each other, but they really are. If this is true, then the following is true. Remember what the log rule says, what the definition of the logarithm says. Go away. I'm just done with it. Okay. That's what the definition of a logarithm says. Now, oh wait, now you drop your absolute value bars. You can't throw away your absolute value bars. Okay, do you see how I did that? Are you cool with this right now? Up to here. And what's 5 to the 0th? Thank you. Yeah. Yeah, you could. You just got to deal with your square roots.
Yes.
You're a step away from done. Yeah. You now get x alone. Hold on. I'm missing a piece. It's 3 to the plus or minus 1.
Right. So what do I?
But that is not the same thing as plus or minus 3. Duffy?
Oh, okay.
Yes. You need to strip away. It's
How do you get rid of?
the absolute value bars that way. You have a positive and negative case.
Oh, okay. Like that?
Yes. Now all you got to do is rationalize the denominator, and your game's over.
Is that right?
It's no. Well, okay. Yeah, that's fine. But remember what the question asked you.
The zeros. Oh,
The product of the zeros. Okay. Now, at this moment, I'm watching a lot of people forgetting an important piece. When you take this square root, you get a positive and a negative, right? The positive and negative square root of 3. Could it be the negative case? All right, you have two answers here. And in fact, you have two answers over here. Could it be the negative cases? Go back to the original question. Can I plug in negative square root of 3 into the equation? Can't take the log of a negative number. So these are strictly the positive numbers. And what did the question ask you for? Find the product of the zeros. And what happens when I take the product of the zeros? Where in mine is it? Right here? Because this is the first rule of logarithms. The base becomes full size. This guy becomes your exponent. And this guy comes out all by himself. Think about it this way. The first rule, the first rule was stated as if and only if. A gets full sized, C jumps up, becomes its exponent, and B comes down all by himself. You're good? All right. Actually, I'm going to leave that up. Are we feeling this a little bit? Now remember, you got to multiply them together. All right? Simultaneous equations, shall we? So, how are we going to play? Solve for x and y. Simultaneous equations. It's a system. And no, you cannot graph them. Whoa. Yeah, I don't like that either. Okay, I mean, it's not the end of the world, but I don't like it. Well, left-hand side equals 1. Okay. Try to split up my logs a little bit. Like that left-hand log, can I break up that left-hand log into what? How can I break up that left-hand log? You got it. That's what I wanted. Well, first of all, that's nicer looking. Okay. And the right-hand side, what can I do with him? I could combine them, but say it. Yeah, move the exponents. And you see now, it looks a little bit less scary. You absolutely, if you wanted to, you could do that and you could rock and roll. Me, personally, I hate writing this same thing over and over and over and over again. When I did this myself, I made a substitution. I said, let A equal ln of x and B equal ln of y, and then it just becomes a snap. And let your algebra begin. See, IB problems very often become super simple when you make a substitution. Because I don't like writing natural log of x and natural log of y 100,000 times, first of all, because it's scary looking. They're all the same. Yeah, you see? They all have them in common. So I'm just going to make my life a little easier. So you can use elimination, you can use substitution.
Well, if you do something, that divides all by 5, so it's the same thing.
And set them equal to each other. But then you're going to have one equation with two unknowns.
Okay.
Alternatively, rather, yeah? A equals b plus 1. And now substitute. Yeah, I think I got something like that. I think something like that. Oh, wait. Yeah. Subtract 3 from both sides, you get a 5 minus 3 is... Thank you. It's okay. It's okay. It's morning. Did you get it? And now solve for y and x. What did you do? Right. Well, do yourself a favor. Instead of plugging it in, set them equal to each other. Solve for a in both cases and then set them equal. Or solve for a in the first one and substitute it into the second one. Not really. What, you found this. You found that. Now, you would have to set it equal to end up with 1 plus b equals 5 minus 2b all over 3. And rock and roll from here. Cool. Huh? Now solve for x and y, not the natural log of x and the natural log of y. Get x alone. Get x and y alone. Now resubstitute your natural log of x and your natural log of y, and get x and y alone. Oh, so you did that on the left. Now get x and y alone from there. Yeah. What you got? Is that a 2? Yeah. 7. Yeah, that's it. That's your answer. don't forget, you found B, and that's great, but now you got to find A. You got to find both A and B. Seventh rule, jack and E under both sides. So you can solve this in any way you please. Or maybe not. Okay, so is everybody coming up with 2/5 and 7/5? Almost? Yes? Now, you got to find x and y. I'm not looking for a and b, I'm looking for x and y. So b was the ln of y. So that means y is equal to e to the 2/5. And the ln of x is equal to was a is equal to 7/5. So x is equal to e to the 7/5.
That's all you have to do. Give it an E.
Yeah, leave it in terms of e. Well, think about what you started with in the beginning. You were starting with the natural log, which usually produces an evil-looking decimal, equaling a whole number. So that means that somewhere along the line, your answer's got to eliminate that natural log, which means e to the something would have to be it. All right, last one of IB evil. And this one was IB evil. I'm saving the best for last.
We just take the class and just not do the exam. Can we do that?
Hey, I already threw away a test.
No, we like not do the IB exam. Like, can we just like take the class?
I don't know. You got to talk to Miss Ellis about that. I don't know the rules. I mean, I don't know what the rules are.
Well, we can just test that. I'm not doing IB anyways.
All right. The first thing that yells at you is what? Yeah, they're all powers of 2. What's another thing that jumps out at you? Different logarithms. Now, I'll tell you one thing that I did when I first looked at this was I said, oh, I can immediately take those exponents down. Right? You could bring that 4x minus 1 and make them a coefficient, and make that x plus 5 a coefficient, and so on. You could do that. But would it help you? And in fact, it causes me a little bit of strife because it means that I can't combine my like terms very well. But I admit, I went down that road. So I really didn't like the third term, right? You don't like the third term either. You don't like the whole problem, do you? No. Yeah, I understand. But 16 in log base 2, that's going to fall apart. Attack that third term. Forget about the first 2 terms. Attack the third term, get that sucker into something reasonable. Just beat the daylights out of the third term and see what you get. now anything to its own base, what happens? Right. And that becomes full size now. And now you can maybe fool around with the other things. Now what's log base 2 of 16? Two to the what gives me 16? No, because that just becomes 1. I know what you want to do. You want to eliminate that, and that's fine. But you can't do that yet because you have that exponent to play with. Bring that exponent down as a full-size coefficient, and then do that.
Okay.
Take your 4 minus 8x, bring him down to the front, and then your log base can go away.
So you get the same thing, but you just have to do it differently.
You don't get the same thing exactly. You can't, you see, right, x is some number. If I found out that x was 3, who cares? I would get in, get the 20th. 20th is a number. I want to take the log of it, I get negative 20 out. Okay? The point is that the exponent survives. The base dies. Okay? Log 2 becomes 1. Now you've got something nice and pretty. So, okay? Now, I'm going to play around a little bit more. Ada. Are we all believing that? Log base 2 of 2 to the 4 minus 8x. Okay. Take a look and see what I did to my right-hand term. Stand up then. Or hold on. A little better. Okay. How are we up to here? I like your left hand. Okay. Yeah, and the only reason why I'm going to say hold off on that step is because you're not going to be able to easily group all of your x's together. And that's what you really want. Okay? It's like if I've always had like a shudder of fear go over my whole body whenever I see an x of different sizes. Like an x in an exponent and x in the base. That scares me. Because that's you got to play some really you got to have some serious pixie dust to fix that. And not having gum in class either. Yes.
Is this,
No. Well, it does. Log base 2 of 16 is 4, right?
So I wrote this to the front and then put 4 and then reverse.
Then it'll work.
Wait, we're not,
What's wrong?
isn't this, the exponential class before you do division or after?
If you do it right now, you should try it. You should try it. But what happens is that you're going to have to distribute because you'll have 4x minus 1 in parentheses times natural logs. All roads lead to Rome. So if you want, go ahead and try it. Nope. Use my log rules. Subtraction of logs becomes division of the interiors. And do we all believe me up to here? I haven't played with anything yet. In fact, I won't need to use Rule 7 on this. Don't need to. Don't need to. In fact, I didn't want to use Rule 7. I was just saying this over there, is that I always get, literally I have a moment of like anxiety whenever I look at an equation when I see x full-sized and superscript. If they're different sizes x's, I get nervous. Why? Because that's when you need serious pixie dust. If you can keep all of your x's in the same size font, you're in better luck. Okay?
How do we get all this?
Aha. We call upon Tinkerbell, who division of exponents is subtraction. You can't exponent. And now I can take my exponent and make him full size. And now my anxiety level goes down, my blood pressure is normalized, and I'm good.
Speak for yourself.
And now solve for x. You don't need to. Just group all your x's together, get them all together. Distribute. I subtracted the denominator. So, yeah. Because the left-hand side, the subtraction of logs becomes division of the interiors, which gives me what I have on the top of my screen right now. And then exponent rules simplifies. Now, right here, gentlemen and ladies, distribute the natural log of 2. So you're going to wind up with 2 terms on the left and 2 terms on the right. Okay? Group all of your x's in one place. Get everything that's not x over onto the other side. And we'll revisit. So distribute right now, everyone. Distribute the left-hand side. It's distributed. Is that what it is? Oh, okay. Let's do that. Is that a Sparkman term?
But you got this step before, you just put 2 to the x minus 16 is equal to, what do you mean by distribute? I don't know something you were not sure. Can you get rid of,
Say that again.
can you get rid of the natural log in the step before?
You would want, again, you're going to wind up with an e. you're going to wind up with an answer in terms of e. And what I really want to do is I've already got x full-sized on the right-hand side. Okay, it's like normal-sized x, right? But my x on the left-hand side is small. It's in a superscript, an exponent. So what I really want to do is I want to get him down to make him full-sized. And now we do. If I were to jack an e under both sides to get rid of the left, right, I'm going to wind up with e to the 4 minus 8x. And now all of a sudden, the left-hand side is full-sized and the right-hand side is small, which is not what I want. I want them both full-sized. So everyone distribute. Distributing the natural log of 2.
So we're dividing 4 minus 8x by both. Oh.
Guys, this is algebra. We shouldn't be having problems at this stage. Group all of your x's together. Get everything that isn't an x over to the other side. I want you to do it, not me. Add 8x to both sides. Add 16 ln of 2 to both sides. Get your x's together. Get your non-x's to the other side. Good. Now you have a GCD of an x on the left. You pull out the GCD of an x and get x alone, and you're done. Both terms contain an x. I'm going to get rid of those. You don't need them anymore. Sorry. Okay, you know what that is. You got a GCD of an x. Pull it out. Parentheses. And then x equals, bring that parentheses down below. Okay. And now you're done. And this is some evil thing, some crazy whack number. No.
That's all you can do?
No, well, you see, that's the thing about IB problems. They are designed by, little minions who are floating around the icy pit of fire at the 7th layer of hell. And unfortunately, they only send us information a few times a year. So, I pulled all of the natural log problems that I could find. I could probably dig up some more, and I also have other textbooks made, not on the 7th level of hell, but on the 6th. So, and I've been giving those problems out as homework, and you guys are coming back wounded. So, that's why I kind of wanted to take part of most of today to do these. All right, are we under control with this? A little bit more? Can we play with logarithms a little bit? Okay, it's like cuddling up to a porcupine. What do you mean it doesn't work? Porcupines are cute. And skunks are like awesome pets, I've been told. All right. Okay. We only have a little bit of time left, so I'm just going to throw a little bit of a reminder about what a factorial is. Okay. This is just a reminder. All right. You should already know this kind of stuff, but this is where I'm going to start the next lecture. All right. Okay? 1 times 2 times 3 times 4 times, all the way on up to n. Okay? Right? This is by definition. Zero factorial is equal to 1, because we need something for that. I know, it's weird, isn't it?
You're making my mind do that. 0 and 1 is not.
That's not math unless it's like math.
It's in order for us to get past this, it just has to be something that we insert into our mathematical database. It doesn't have to make sense. But and later on, I'll try and give you a better proof of it. Now, to get these values, all right. Now, you will, if you were to compute these out, 5 times 4 times 3 times 2, right? That's 120. 5 factorial is 120. It gets big fast. Okay. So if you had something like this, ten factorial, 10 times 9 times 8 times 7 times 6 times 4 3 times 2 times 1. That's really big. Yes, you can. Think about this. Counting, Bronco, counting. Right? True? Right? 7 times 9 times 8. 10 times 9. Okay? How about this? Well, watch. You see, 6 factorial times 7 becomes 7 factorial. And now I have a GCD. Yeah. What? How did I get it?
No, I understand.
Well,
I got it. I just would never know. Yeah, I never was on that.
well, 7 minus 1, right? Well, first of all, I look at what 7 factorial really is. It's 7 times 6 times 5 times 4. Well, 6 times 5 times 4 times 3 times 4, that's 6 factorial. So I,
Oh yeah, be the 5 and 6.
5 and the 6, the 5 factorial and the 6 factorial simplify. So this becomes 6. And this is Does that make sense? Okay. Cool. Now, you would do the same thing, right? But you would wind up with 6 times 8 at the end. Okay? But this all by itself, just in general, when you're adding factorials, okay? Or even still, if I did something like if I needed to find that, you would not want to multiply 9 times 8 times 7 and then add it to 5 times 4, all waste of my time. Do this. See how I did that? Because what is 5 factorial? So I kind of just stop writing this long string of multiplications by saying, hey, that's just 5 factorial from here on out. And now I have and that's 72 times, 56 times 6, that's 336 times 9. 336 times 9, 99, 297, 297, 722, 304, 4. I think. Ah, my fault. Yeah, well, you know, numbers rolling around in my head. I looked at it as, well, I did 56 times 3, 56 times 6, which is 3,000. Oh, sorry, yeah, 336. And then I did multiply that by 9 by saying 9 times 33 is 99 times 3, which is 2,976. And then I did 9 times 6 and added it to it, moving a decimal point. Yeah, mental math. Yeah, you can. Yeah, we all can do that. All right, but these are the rules, and I'll post a homework assignment for you. It won't be too bad. Just exercises on factorials. Okay. Maybe a few log problems, if I can find one or two. Everyone, have a great day. This episode of the Ronco Show has been brought to you by 5 Factorial and the natural log of E.